A/B testing, but sometimes the mathematicians, the scientists are call it is as a bucket testings or split run testing or control experiment. There are various kind of names. So, but in generally we have used this as a A/B testing. Okay, sometimes it is called as a bucket testing, or it is called like a split testing, or you can call it as a controlled experiment. Okay, so there are the three difference. Now let's try to understand. Actually, in this video, we will cover basic of A/B testing, but there have a whole semester course on A/B testing. Okay, just I am going to give you some flavor onto it. How these things are actually workable on machine learning world. Let's see it. Suppose, suppose it's first try to understand these things through a medical problem. Medical problem. Okay. Suppose in a medical problem, for cold, there have already one existing medicines in the market. That medicines is called. Let's call these medicines as M old. Already these medicines is already exist in the market. And now one new company come into the market and they have produced another new medicines for this same cold problem. Let's call this medicine as a made new. Okay. Now our job is, and already they are have one type of another type of medicines. Let's call no dark medicines means they have some type of tablets like that, but they have no content, no drug. Okay, this may be content little amount of drug, but they have already exist in the market. They have no dark medicines. Let's call it is a no drug, no drug medicine. Okay. Now our job is to compare these new medicines to the existing medicines and no drug medicine. Is these new medicines is better or not? If these things happen better, if this output give better, then it's exist in our market. Otherwise, it is has no sense to be in the market. So our now job is to compare these medicines to the existing medicines means medicines old and medicines they have no dark. Okay, we have to compare. Now how we will doing this simple job? So first thing, let there have some users, group of users we have. Let there have some group of users we have. First thing that we have to do, we have to split the our whole users randomly in two groups. We will split this users set of users in two groups randomly. Suppose let's one group is A and another group is B. And let we have doing this random splitting onto the 50% for group A and 50% for group B. Okay. Now after splitting this, that the thing that we have to do, we have to apply our test, our old existing medicines onto our market, aim old on one group and the new medicines on the another group. Okay. So first let we apply on this group the aim medicine old we will apply. And on this another group B, we will apply the another medicine new. And after applying it, Somehow we got the results. After applying this, we got the results. It gives the output within 2 hours. Within 2 hours. And after applying this new medicine, suppose let's we got this output within 1 hour. Within 1 hour. So these things means already old medicines are exist in our market, but in the new medicine has come into our pictures as new into our market. But okay, so since for this test, for this experiment, we have seen that our new medicines give better result, then we can conclude yes, our new medicines is performing well than old medicine. So this is the simple technique to the A/B testing. But actually in the real world, that things are not. Okay, these kind of things are actually experimentables in the medicine world. Now let's try to understand these things to the machine learning world. How these same things are actually workable in machine learning. Okay, let's take. Since the number of group of users we have small, then we can doing this job. But yeah, our number of users of billions of billions of users in today's world. So in such scenario, how we will apply this machine learning? How this apply it? This A/B testing. Let's see it. Now let's try to this thing. We try to understand this A/B testing in machine learning point of view. An example. Through an example. Let's try to understand it. Suppose let suppose let we have want a model that have predict the Google which are at have to shown in each search query. Okay, that's the thing that we are want to build such models that Google will want this type of model. For each search query, they will want to show some ads on the particular search query. Suppose let's you when you search on something on Google, when you search on something, so this is the search bar, you are writing something onto it, then you have seen first 2 or 3 rows, you have seen some ad that have shown at one. In the second row, in the second web page, you have shown this is the ad two. The third web page you have shown it is the ad three, like that. It's depend to problem, specific customer to customer. This kind of ad Google, and after that they will give the original search query. After that is the original search. This is the original search query. But the main problem how the Google want to predict, want to build such models, that models will predict this kind of ad, which ad will be relevant for a particular search query. This kind of apps Google will want. And from this ad, Google are actually income. Google actually income billions of dollars. Okay, by simple showing this ad on a search query. Now the question is, since it is a $1 billion problem, we have to build such model that will perfectly predict which ad will be more relevant for a search query. That's the job. That the thing that we have to do. Okay? So that the job that is the model, we have to make some model for Google, right? For Google that predict that predict okay, to when ad to show, to watch which ad to show for a particular search query. to which get to show for a such query. Okay, that's the thing that we are interested. Okay, now simple. This is a one kind of, you can think these things as a one kind of machine learning. You can think these things as a, okay. Now simple, we have used here the A/B testing to which models is better for. Okay, simple, we have used here A/B testing or model, which models, which model is better for us, because for these things we have used here A/B testing. Means already we have learned some basic machine learning machine learning models like a supervised model, unsupervised model, clustering model, classifications model, regressions model, like that. But now somehow we using the data sets, we build some models. Now the main thing is which models is better. We justify these things. This is the main thing. This type of testing actually work in, actually needed in real world. Okay, now let's see how we will use these things in such particular problem. For the models that will predict which ads, which give the better, means better relevant ad, which models give the better relevant ad for a particular search. Okay, that's the thing. Suppose, let we have some group of customers. In Google, there have billions of customers. Suppose let's we have some billions, 1 million customer. Let 1 million customer. Let, okay, we have users, means I'm talking 1 million users. We have, so first thing that we have to do, we have two models, M old and M new. M old means old model that already ran through Google, and somehow developing something, somehow the changing some strategy, Google have built some new model for this particular job. Now our job is to predict which models is better. If we changing our strategy, if we make some assumptions and develop some models, it's not always true that give the always correct output in a real world. Now the main thing is you have to testing these things in real world through the users. Actually, these models is giving better output or not. That's the thing. Okay, these are the simple old model, and this is the simple new model. This is the simple new. First thing, we have to split the whole data into two parts. It's randomly splitting. Obviously, randomly split here in group A and group B. Okay, we are randomly doing this job first. In group A, means one thing that we have to remember, we have not doing this job 50-50. Since we have nothing about our new models, actually it is $1 billion problem. If we send all the customers, suppose we have doing this 50%, 50%. We are doing 50% for old model and 50% for new model. Okay, if we apply the 50% customers and 50% for the new models, Suppose our new model is actually not good in the real world. Then what happen? Then this 50% customer will face some problems. Since it's a billions dollar problems, so company has chances to lose their money. So it's not a correct strategy. So in such scenario, we have not like the 50-50. We will apply the 90% for already existing models, and we have taken some little users for the new models. Suppose we are now randomly splitting 90% users for the old model and 10% user. Only we have used 10% user to testing our new model. Okay. Now on this 90% user as regular, we will use our old model, and on this 10% users, we will apply our new model. Okay, that's the first step, that the thing we have to. Okay, and now after sending all the things, we have got some input from our users to the old model as well as new models. Suppose we got the input from old users. Suppose for after showing this ad, old users click some ads. Let's call this click is CA. Click through the group of users A, and NA means the number of times ad has been shown to the users of the group. Okay, so it will be better if you write it. EA means number of clicks by the users A, and NA means total number of times ad has been shown to the users A. That's the simple thing. Okay, we can easily count using some technique, means programmatic technique. We can easily count this number. Similarly, for here also we can count CB and NB. CB means the number of clicks by the users of the group B. The NB means number of times ad has been shown to the group of users B. After that, we have to calculate the CTR value. Now let's see what is CTR. CTR means click-through rate. Full form is CTR A. It will be simply the CA by NA. Okay, so first write it. What is CTR? Click-through rate. Click-through rate, it will be simple. The number of clicks of particular group divided by the number of ads has been shown for that particular group. Ad has been shown for that particular group. That is the simple formula of the CTR. Let CTR A for this group is equals to A, CA by NA, and CTR B for this group, CTR B. CTR B, it will be CB by NB. Right. Okay. Now after that, if we find CTR A is less than CTR B, then we can conclude that yes, CTR model new is good if we found CTR A is less than is equals to CTR B, then you can conclude yes, our model new is okay. But the questions that is not only particular day, single day, if we perform a single day, we will get this value. Then we cannot decide. We have to run various day, and if if continuously you got this kind of results. Okay, suppose we have performed it on day one, we'll perform it on day two. After performing it, we got it on day three, like that. Suppose in 1 month, if you perform these models and you got the same kind of results, 30, same kind of results. If you got, then we can conclude that yes, our since in 1 month our model knew which give our this kind of results. We can conclude that yes, a new is better than a old. Okay, then we can conclude this. Now there have some problems also. Now let's see what is the problem. Actually, that thing that you have shown, we have doing these jobs through the online mode. Online mode means it's real, it's the production box. These testings are actually applying on a production. It may be a website, it may be through a applications like that kind of. Means user interface things. We will be doing this job. Okay. So now let's see what is the problem on these things. So first to resolve this, perhaps try to understand this problem. Then we will try to how will using simple probabilistic technique how will resolve this problem. Let's try to understand it first. Now let's see what is the problem of this model. Why actually we have changed some we have made some modifications. Okay. So first after applying this, after experimenting 30 days, up to 30 days, if we got some constantly this kind of results yet we have seen. Now how will change the things in productionization box. Suppose it's the group of users that we have taken for testing. We have taken here 90% of users, and on the group B we have taken here the 10% users. Okay. Now on this group users, here we have seen that we have applied on our old model, and here we have applied our new model. Okay. So first, after applying, we have taken some confirmations. Okay, our model group is okay. Now after some time, as time programs, we have changed our customers to group A to it means old model to new models. So first we have taken here 95%. First we have taken what 95% for the group A and 5% for the model B. So after sometimes we have taken here 90% for the group A, and means here we have decreased the users, here we have increased the users 10%. After some time here we have taken 80%, here we have taken 20%, like that. After sometimes here we have got 50%, here 50%, like. And after sometimes we have taken here 0%, here we have transfer all the users. Once we have slowly transformed the maximum users from old model to new models by simple showing these results. If we after some time, if we show after suppose after 3 months, if we show this the CTR value has changed, then we have to need something further. We have to need to think something further. If all the things are happen well, suppose we have doing this experiment up to 3 years, and till 3 years we have shown that our result CTR A is less than CTR B, then we end doing these jobs, it's okay. But if we think after 3 months or 4 months, if we see the CTR value has changed, then we need to think for the further steps. Okay, that's the. Now let's see what is the another problem there we have to face. So let's see it. Suppose we have two group of users. It's group A and it's group B. It's group A and group B. And group A, we have CA. Some CA click through rates for the group A at N A, number of ad. And here also there have some CB, NB. Okay, these two numbers we have. Suppose since we have seen here, at the first we have used the old models on this group A users and the new models on the group B users. Okay, now we have since we at first we have to transfer all the traffic to the new models, means we have to take. So these are the two groups A and B. This in group A we have applied old models, and in group B we have applied new models. These are the click rate, and this is the number of ads total has been shown for these two. Okay, these things. And we have seen in old model that we have at first we have applied only 95% users to the old model, and only we have used 5% or 10%. Means maximum users is we have taken to our old models, but some little amount of users we have converted to our old models randomly. That's things also randomly, obviously. Suppose for these users we have got somehow, since it's the 90%, 95% users of our whole users we used. Suppose we got some rate here, 100k. 100k ad we have 10k ad we have shown for this particular user group of users, and we have got it click through rates 100, click rate 100 on these things, and we have shown it 10k times. Since it's only we have used a 5% users, here we have shown the 100 ads. Let these things, or let we have taken here late, and we have got the clicked on this 100 ad. We have cleared click only 2. Here we got the click only 100, only 100. Here we got the click only 2. Instead of 10,000, here instead of 100. Okay. So what will be the CTR value now? Let's count it. What will be the CTR for this group A? 100 by 10k. 100 by 10k means it will be 1%. Here what will be the CTR value? CTR B, it will be 2 by 100. It will be like 2%. Okay, so we can conclude from this result, we can conclude that since CTR B is greater than CTR A, our models B is better than model A. Since CTR A, since we have seen here CTR B is greater than CTR A, therefore we can conclude that model new is better than model old. But the thing is, it's totally wrong. But these assumptions is totally wrong. These assumptions is totally wrong. Let's see why. Why actually these assumptions is wrong? What are doing? I have some mistake. So let's see it. Since the main problem is here, since we have used only 100 users, only 5% users randomly. So based on these 5% results, we cannot conclude this thing. Okay, since here we have huge amount of users, so there may have some chances. If we're doing the same experiment again, then we can go to the different result. Okay, it's not a perfect strategy by using the based on this simple CTR value. If we make some conclusion, so to avoid these problems, we will use the confidence of interval concept that already we have seen, already we have learned in the chapter of probability and statistics. So the concept of confidence of interval come into the pictures. We have used here the confidence of interval on CTR value. The simple thing, the simple. If you forget this, what is confidence of interval? I suggest you please go to this probability and statistics sections. Just revisit this those videos. Then you can find his answer. Now we simple apply. So suppose we have taken here the 95% confidence interval. Let we have interest to 95% confidence intervals for each CTR, for CTR, A or and B. So suppose after finding the confidence interval for CTR A, we got this range. We got the CTR confidence interval of CTR A, we got it like 0.8% to 1.2%. Since we got it, the CTR value is 1%. Suppose let's say 95% confidence interval is this range, lie on this range. This is the 95% confidence interval. Okay. And for this is the for group of A. Now let's see for group of B, the confidence interval will be better if we say. This is for group of A. Now let's see for group of B. So confidence interval of the CTR B is equals to, we got it 2%. Somehow, suppose let's its confidence interval is 0.55%. Let it to 7%. This is the confidence interval. This is the 95% confidence interval. We got it. Okay, this is the simple thing. This is the value we got it. Just now the question is, now see these two values, these two ranges, intervals. If you think the 1%, the CTR that we got here, this is more tighter than this one. Okay, this is the more spread type. Means this interval is more tight value, and this confidence interval more spread type, spreading type. Sparse means it's larger than this window. Okay, so if you one technique, it is to compare these two CTRs in confidence intervals in interval situations. So it will be like that. Here somehow middle we got its CTR of A, we got it 1%. Okay, and it is the lower value of this CTR, and this is the high value. So its low value we got it 0.8%, its high value we got it 1.2%. Similarly as well here also, here also CTR B, here it is the low CTR of B, it is the high of this CTR of B. It somehow it got it, what is we got it for CTR B, we got it 2%, got it 2%, and its low value we got it 0.55%, and we got its high value 7%. Okay, but see it, this is the more spreading window than it. So if you just merge these two windows, it's just think these things like a window frame. Okay, if you merge these two windows, then you can got these final pictures like that. Like that. So here somehow suppose let its 0 is here, 0 is here 1, here 2, 3, 4, 5, 6, 7. Here it's suppose let's I think it will be better if we point there have it's here. I think it will be better if we spread it and it will be better for understanding. Okay, no problem. Let this one here somewhere here -1. -1 here -2. These portions in I'm interested. Since we have first let's plot it to this color. This CTRA. CTRA is here somehow here and it's 0.8% here and it's 0.12%. 1.2% means somewhere here it is 1.2, like this window frame, like means it's 0.8% and it's 1.2%, like that this window frame. Now for look that now look the CTR. It will be better if we just a little bit zoom it. Okay, it is now better visualize. Let's now now CTRB. CTRB is 2.2% is here. This is the CTRB and the lower value of the 0.55 here 0.8 means somewhere here it will be somewhere here it's 0.55%, here it is 2% and its higher value is 7%. 0.55 to 7% means somewhere. So it's, if you see these windows, see it's like in that way. Okay, from this experiment, from these pictures, I think you got the idea. I think you yes, it is okay. Just okay, it's okay. Okay, I think from this picture you got the idea. Just see it. The Windows frame of the CTRB, each containing the Windows frame or CTRA. So this window, this color window is the for CTRB, and this small window onto it, it's the Windows for CTRA. Now let's see it. How much tight means how much confidence we have this. Since we have 90%, 95% confidence of this 2%, 2% CTR value, but its variance is so high. Okay, that's the simple thing here. And its seed variance, its variance is so low. That's the main concept. Because of this problem, since we have small amount of users, we only use the 5% users onto it. So because of these reasons, this is the main problem of onto it. Okay, these are because of these problems. So there have various technique to take it. Now let's see. So because of these reasons, the CTR value is not sufficient enough to make some conclusions. Okay, just see this from this confidence interval length. Okay, just see it. Because of this inequality of the users, we got the different kind of confidence interval value. Here, this is the 95% confidence interval. Here is also 95% confidence interval. But see the spread, the variance of this confidence. Here variance is so small. Here variance is so high. Because of these reasons, we have used 90% use, 5% users for these old models and 5% users for these new models. And it is not a always better task. If we equally distributed this all the users for the new users, so we don't know anything about our new models. Based on some assumption, based on some characteristics, we build it. It may not be work to our real world data. So this is the main reasons, and they are half. Actually, if you think these things, it's like a whole semester course for this A/B testing. Just I am want to give you some flavor onto it. Okay, so first now on the basis of this confidence interval, how we'll decided which models is better, which model is not. So simple, we have used this CTR value. CT confidence interval of the CTR, this is for the group A, and this is the confidence interval for the CTR of this model B. And on these models, suppose it's the confidence interval is the CTR value, and it is the suppose it's total not overlapped, it's totally unoverlapped. Okay, and the size of these distributions is equally. These distributions means what? This length is, this window length is what? This is the variances. This is this spread, the window spread that you think this high value and low value, high value and low value of the confidence interval, you can think like it is a variances. Variances of A, and this is the variances of the group of B. This is the simple thing. Okay, that's because of these reasons. If our variances is somehow equal, somehow not accurately, but somehow not more deviated, and it's one is greater than the other. If these things happen, if this kind of situations happen, then we need to conclude yes, our model B is now better than model B. If this all the things, if such kind of things happen, if this both means first one is variance are equivalent, variance of A are equally, not exactly, but somehow equally of the variance of B, and first one, second one is the confidence intervals. If this confidence intervals of the CTR value of group A is it's strictly less than, means that they have some mathematical formulas to compare the interval technique for one interval to another interval using these things kind of thing. If somehow you have seen that this is strictly less than this CTR of B, if this kind of situations happen, then we can conclude yes, our model new is better than model old. If these things happen, then we can conclude these things. Otherwise, we have not made some conclusion. Okay, so this is the thing, and it is the one semester full fetch one semester course. If you interested, then you can learn it. In real world machine learning problems, these things like this kind of probability, this probability are actually. I think you have got the idea how much probability is important to the real world scenario. When you discuss the case study, when we apply the A/B testing onto it, then you have seen, then you will see how much important it is. Now let there have one type of another kind of testing technique. Let A/B testing. Till now we have seen the A/B testings. There have also another kind of testing. Let A/A testing. A/A testing is the same concept, also just in different angle. Means here in A/B testings, A/B means we have taken here two different group on for two different models. Here we have applied the same models but two different groups. Suppose we have some users, and we have randomly split or hold the users into two groups. A, we call it A, and another group also we call it A. And on these two groups we apply different models. Same old, same models also we have applied on this group. Okay, this is the randomly split it. If we doing these jobs in real world, then you have seen this CTR value. Suppose we got it the CTR A, and for this A we got it the CTR. Let's call it A dash, CTR A dash. we have applied that both the same models, but these two CTR values are different. It's not equal. It's totally different. Okay, this is the simple AAA testing. Means we have randomly split these two group of users, and each each user's choice is different, each user's strategy is different. So because of this reason, since we have applied the same models, but the main problem is the CTR value may not be equal. It's changing, always change this thing. Okay, this kind of technique are called the AAA testings. For single models, for single model, we will apply these things, and the main applications of it is to find the variances of the okay. So if these things differ so much, then we have, if this is one technique, these things, if CTRA is CTRA does differs so much, if these things differ so much, then we can conclude that, and a model, our model, a mold, are not are makes huge differences. Means for two different group of peoples, it makes so different behaviors. Is not correct. Is not correct. Or in another language, you can think it's you need to improve. Okay, this kind of things is called the AA testing. For a single model, it's mainly used. Now there have another type of testing, AAB testing. AAB testings. So AAB testings is look like that. Here have a group of users. It's let this group of users somehow view. This is the group of users, and we will first randomly splitted this whole group of users into three groups. Randomly splitted these things. Randomly splitted in first group A, similarly A, and again B. On these two groups, A group, we apply our old model. Again, this A group, we apply our old models. On this B group, we apply a new model. Okay, that's the thing that we have to. So here, let's call this CTR value for this group is CTR A. Let this CTR value A dash, and let its CTR value CTR of B. CTR of B. Okay. So if somehow if somehow after experimenting this type of testing, we got it some CTR value, let 5% we got it, and after experimenting we got it some CTR value, let 5.5%, and we got it 5.4%. So from these two things, you can conclude that, since just see the first, if you compare these two models, CTR A and CTR B, if you compare it, then you can see that this CTR B is greater than CTR A. Then you can conclude that yes, our B model is new model is better than old model. But if you conclude these two things, two models, but if you conclude these two models, then CTR A dash is much larger than this one. So this is the two different kind of assumptions you got. Okay, since we have taken the random type of users, since from this here we cannot conclude that model new is better than model old. So from just see it, if you see it, from these things we can conclude that model new is better than model old. But from these things you can conclude that our model old is greater than model 2. So just see it, two different kind of situations. From this A/B testing, so we got different assumptions, but we simple the A/B testings onto it, then we might net conclude that yes, model new is greater than model old. But actual scenario, it is not happen. If you use this A/B testing, it's another kind of technique to justify two different models. So the same, just because of this randomness, because of this because of this randomness of the splitting of the users, just see this group A and this A group, CTR A and CTR A test, we have different values. Okay, but this model is same. You can think these things like a testing, and we have apply onto this B model on this another group. Okay, since these two variances is high, since this variance is high, and this CTR value is lying on that variance, so we may conclude that our model, we have some better improvement to our new model. So we cannot conclude these things here. Let's see, because of this reason. So there have various few steps to conclude to make some decisions on the basis of our hypothesis. First, we have to test A testing, how much variances they are have or not on a particular models. If these things okay, if we compare to different type of models, so you have to use first A/B testing, then we will use the AAB testing, like that kind of models. So actually, from these discussions, I am going to give you some flavor of these A/B testings, but they have a whole semester course onto it. Okay, if you are interested, just search it on Google. You can easily find there are various books available, there are various research paper available. If you're interested, then you can just study on yours. Just this is the, I will give you some example how these A/B testings are, how this probability concept and statistics concept are useful in real world problem. Okay, that's the simple concept. Okay, when we discuss the case study, then in detail we will see how much important these things is, how much important in the probability and statistics is in the real world. Okay, we will see it when we discuss the case study.